This is a tutorial for creating a part program for your Keychain in SolidCAM. First, open your part file in SolidWorks, and then go to the SolidCAM 2010 tab and select New and then Milling from the menu. In the pop-up window, make sure the box that says Use Model File Directory is checked. This will ensure that your SolidCAM file is saved in the same location and with the same name as your part file. Select OK to move to the next step. To select the post processor for the correct G-code generation, go to the CNC controller section on the left-hand side of the page and choose G-Milling 3X Haas V2 for the Haas or G-Milling 3X Micro K for the Micro Ks. To create a coordinate system, click on Define. Make sure that Select Face and Corner of Model Box are selected. Click on the top surface of your part. It should turn yellow and a colored coordinate system should appear in one corner. This coordinate system will have the same colors as the universal coordinate system in the bottom left corner. Blue is Z, green is Y, and red is X. Flip the settings shown until the coordinate system is in the correct orientation, with Z pointing out of the top of the part and X and Y pointing into the part. Then click the green check mark at the top. A new window pops up for working dimensions. Set the clearance level to 1 inch, the part upper level to 0, the top surface of the part, and the part lower level to a negative 0.3 to ensure the mill goes through the entire part. Then click OK. Click the green check mark to finish this step. Next, click the Stock button and select Box Auto from the drop-down menu. Then select Define. Click the top surface of the part and a green wireframe box should appear around your model. Then click the green check mark 3 times to finish the milling part data section. The first operation is the rectangular pocket. Right-click on Operations and select Add Operation and Pocket. To define the pocket, select Define in the Geometry section. On the left-hand side, scroll down and select Auto Constant Z. Click on one of the top edges of the cut and then on the red arrow that appears. Click Yes in the OK to Accept window. Then click on the green check mark. To define your tool, go to the Tool section and then click on Select. Click on Add and then select End Mill for the tool type. Enter the correct diameter for the mill you're using in the diameter box. In the Default Tool Data tab, set feed XY, feed Z, and the spin rate or spindle speed to the correct values for the mill as given in your lab manual. Then click on Select. Go to the Level section and click on Upper Level and then select the top surface of your part. Click Pocket Depth and then click on the bottom surface of the pocket. Next, check Equal Step Down and set the max step down to the correct value for the mill. Click Save and Calculate and then Simulate to check that the operation is correct. Make sure the yellow toolpath covers the inside of the pocket and moves in multiple steps from the top surface to the bottom surface of the pocket. Close the simulation and then exit out of the Pocket Operations window. Operation 2 is the freeform cut in your part. Right-click on Operations, go to Add Operation and Pocket. To define the pocket, select Define in the Geometry section. Scroll down and select Auto Constant Z. Click on one of the top edges of the cut and then on the red arrow. Click Yes in the OK to Accept window and then click the green check mark. To define the tool, go to the Tool section and click Select. Pick the tool you created in the last operation and then click Select again. It's a good idea to do a quick check of the tool data to make sure that the feeds and speeds are still correct. Go to the Level section and click on Upper Level. Select the pocket surface and then the green check mark. Set the pocket depth to be 0.05 past the bottom of the part, or 0.175 inches. Check equal step down and then set the max step down to the correct value for the mill you're using. Click Save and Calculate and then Simulate. Check to make sure that the operation looks correct and the mill moves in multiple steps through the bottom surface of the part. Exit out of the simulation and the pocket operations menu. The third operation is the keychain hole. First, add a pocket operation. Then select Define in the Geometry section and scroll down to Auto Constant Z. Click on the edge of the hole and then click the green check mark. To define the tool, go to the Tool section and then pick the tool that you created during the first operation. Next, go to the Level section and click Upper Level and then select the top surface of the part. Set the pocket depth to be 5/100 past the bottom of the part, or 0.3 inches. Check equal step down and set the max step down to the correct value. Click Save and Calculate and then Simulate to check your operation. If it's correct, exit out of the simulation and the pocket operations menu. The fourth operation is the profile cut. Right-click on Operations and then select Add Operation and Profile. To define the profile, select Define in the Geometry section. Then select Auto Constant Z from the left side of the page. Click on the edge of the part and you will see the perimeter highlighted. Click Yes and then click the green check mark. Define the tool as in the previous operations. Go to the Level section and click Upper Level and then select the top surface of the part. Enter 0.3 for the profile depth, which is 5/100 below the bottom surface. Go to the Technology section and check equal step down and then enter the correct step depth for the mill. Click Save and Calculate and then Simulate. Check to make sure that the yellow tool path lies outside the profile of the part. If it doesn't, as shown, exit out of the simulation and go back to the Pocket Operations menu. Under Modify, change the tool side in the drop-down menu to the opposite side, right to left or left to right. Click Save and Calculate and resimulate, making sure that the tool path is now outside the part. Exit the simulation and the Pocket Operations menu. The last step is generating G-codes for your part. To look over all your operations prior to generating G-codes, you can check the boxes next to each operation and the tool paths will show up on the screen. To generate the G-codes, right-click on Operations and then select G-code All and Generate. Your G-codes will automatically open in Notepad when they're generated. Look over these codes. The X and Y coordinates should all be within the part dimensions, about 1.5 to 2.5 inches. Your tool change line, MO6T1, should be T1 and not T2 or anything higher. Also check your spindle speeds and your feed rates to make sure that they're correct. Once you've looked over the codes, make sure you save your file. Rename it with a .cnc file extension by typing in the new name and selecting All Files as file type before saving. Your G-codes are now completed. Make sure to simulate them before you mill.